on NIME analysis and Microsoft Azure, but I couldn't do Microsoft Azure because of time, and also there was a distraction. So I just want to touch on the Microsoft Azure today before we end the session. So I'm going to share my screen now. It's an hands-on class, but don't worry, I'm going to send the slide afterwards. So the slides for this, so if you are going to have a brief of how to do the analysis as well using either NIME or Microsoft Azure. So I asked us to create an Azure account. I don't know if we all tried that. Was anybody able to create an Azure account? Okay. Let me just run us through them. Can you see my screen?
Yes.
Yes, ma'am.
Okay, good. Okay, so Microsoft Azure is a suite from Microsoft that allows you to log into many services. So it's a very common, it's a very popular platform now, and people use Azure for many things. So this is Microsoft Azure, um, azure.microsoft.com. To get on Microsoft Azure is free, but as you use the service, you need to pay for what we call subscription. People use Microsoft Azure for cloud, for database, for machine learning. They have a lot of resources, but um, I just wanted to touch on the machine learning part. So this Microsoft Azure, you can just click start for free to register. It's very easy, put in your details. But let me log into my own account so that you can see the environment, and then I'll go into their machine learning studio. Okay, so like I said earlier, on um, Microsoft Azure, you can access a suite of many services. You use it for machine learning, you use it for cloud. You can have a virtual machine on Azure. You can also deploy your app on Azure, but I'm not sure you can't deploy, they don't have, you can deploy .NET application, but they don't have for Alpha 5. For Alpha 5, you use Zebra hosting, and so there is also a hosting service. You can have a database as well on Azure, and many more services. So it's a suite of many services. So for you to access any of their service, if you are not sure, instead of searching, what I do is I just come here and I just type the service name I want to access. So in this case, I want to access the Machine Learning Studio. So for Azure, you don't need to install anything. It's available on cloud. Unlike for Nine that you needed to install the Nine platform, but for this you don't need to install anything. So this is what we want: machine learning studio. This is what I want. Or you can also access directly. Can just come and do, let's access directly. Azure Machine Learning Studio, studio.azureml.net. Right. Um, so you just, let's see, using this account. Okay, so on Microsoft Azure, your machine learning flow or process can be created under workspaces or what we call experiments. Um, so I'm going to create a similar workflow like we did last week. So under experiment, um, you just create a new experiment. Okay, so let me create a new project first, and then I create an experiment on that. So I can call this test project. So under project, you can create a new experiment. Okay. So you create a blank experiment. Yeah, so this is what we want. You can rename your experiment from here. Let's create a similar workflow like we were doing last week, the Titanic project. So remember last week we went to a competition site, we downloaded data. So the same process we did on Nine, we are going to do it now using Microsoft Machine Learning Studio. So it's actually very similar to Nine as well. It's just drag and drop um, um, for you to create your analytics. So I'm going to pop up the data that we used last week. Let me check where it is. Okay, I stopped sharing. Let me share back. Okay, so this is where we have. Okay, yeah. So last week, remember we downloaded this Titanic folder, right, from Kaggle competition site, right, and it contained a test data, a train data, and then a submission type. So what we are interested in is the train and test data. So remember the train data had the columns, right, and um, each of these columns represented variables for which we can do a prediction. So we want to do a prediction on whether people survived or not. So this is like a form of classification prediction, right? So this is the train. Now let's look at the test. So for the test, we're going to have the survived column missing because we're predicting on survival. So you can see there's no survived column here. So now let's use these two data in our machine learning workflow. Okay, so let's come back here. Okay, so for a workflow project like this, the first thing, of course, you want to do is to bring in your data. You need to pick the tool, the drag and drop tool, just very similar to Nine. So the tool is here. This is the dashboard where you are going to create the workflow. So we're going to bring in import data. So just drag and drop import data. Once you pick the tool, you're going to see the properties of the tool on the right. So here on the right, you specify the data that it should import and then the file format of the data. So our file format is CSV. It allows other file formats like Excel. Um, let's then specify where the data point is. Let's see. You- Okay, there's an issue here. It requires me to have an account before I can use this import tool. Um, but I have a free account on this, so meaning I can't use this. So we might just use the sample data set. Okay, let me use a sample data set to demonstrate this to us. Let's view the data set. Um, mhm, Class age. Let me see. Okay. If I can't use this import tool, let me use another option. Let me use new data set. We're going to come here. Yeah, let's leave the experiment. Let's import our data as a data set and then bring it in from that sample. So on that data set, come here, click new, then upload from local file. You can either bring in your data set from here or you use the import tool. But for the import tool, you must have an account. Um, I mean, you must have a subscription with Azure, which is paid for. But for the first time, if you are creating your registration for the first time, you get a free subscription for a month. But I no longer have a free subscription. So let's use this import from local file using the data set. So here, let's choose the file. This is the folder, and then we pick our train. So, so let's give it a name that is Titanic train. It's uploading the data set. So I'm going to upload both the train and test from this point so that when I need it in the workflow, I'm just going to call it from the data set. So I'll call this Titanic test. Okay. Yeah, so we have the train and test in the data set. Now let's go back to our experiment. Now, the beautiful thing with Azure is that you can use this Azure for live projects and have all your machine learning process and the deployment and even the web service available within your machine learning studio. So if you look at it from if you look at this right leftmost column, you can see projects, experiment, web services, data set, trained models, and Of course, under settings, you can change your profile. But um, what I'm particular about here is that you can create projects to organize your experiments. So these projects are like workspaces that you created in Nine. Then experiment is each flow, a data process flow is created as an experiment. Then once you are done with the experiment, you can deploy your experiment as a web service. It then provides you like an XML link with which you can test new data sets, and then you can also use this data set to bring in your data or to store your data within Azure. So it's very, very comprehensive, and um, is most enterprise organization use this Microsoft Machine Learning Studio for creating analytics on their data. Okay, so now let's go back to our experiment. This is its Titanic project. So we just click on it. Okay, so now back to our import data. Um, where okay, let's use saved data set. So the data set we imported, we should find it here now, hopefully. Titanic. Okay. Okay, this is sample. Okay, go to my data set. You find it under my data set. So these are your data set. Let me delete this and then bring in my own data set. So I'm starting with my train. So this is my train data set. So just drag and drop. Now, if you want to view the data, just right click, go to data set, click on visualize. Right. So the data set we had in Excel, we can see it now in Microsoft Azure Machine Learning Studio. So this is the data set. Now, um, let's minimize this. So on Microsoft Azure, when you view your data set, it also gives you general statistics of your data set. So for you to view those statistics, just click on each column. Whatever column you're on, you see the statistics of each of the column. Right. So this is process flow for creating data analytics. Of course, you can use this for massive data and even for small data as well. So all of this you can do without writing Python code or without writing code. Once you just um, have a good knowledge of how to use this tool. So this is our train data. Now the next thing you want to do, we want to create a prediction on survived column, remember. So we've just brought in our train data. So we want to pre-process our data. The steps to pre-processing, just like we did last week, is to check missing value, replace missing values, normalize your data, and then you can also check the skewness of your data as well. So let's visualize again, um, and observe each of our data. I want us to see various things that I explained using statistics. Now, remember I said passenger ID is very useless, as in is no, it won't be of any value for prediction. And for you to also validate that, if you look at the plotting of that column, you can see that it does not make any sense, right? So passenger ID would be removed. Then this is survived column. It's 0 and 1. So you can see the two bars. This shows you the two values as um, as bar as bars, sorry, on your graph. You can also see a count of each of the values. Yeah, so this is, yeah, you have more zeros and then fewer ones. So you have 549 um, rows that are predicted not to have survived, and then you have 342 rows that are predicted to have survived because they have value 1, right? So this is the P class. You have three values in it, 1, 2, 3, right? This is the name. This is also useless for prediction because each name represents a value. So we are also going to take out this column. This is the sex for the data. You can from here see the variance in the number of males and females. So there were more males on the ship than females, right? Then this is the age distribution. This seems fairly okay. It is not skewed. It's somewhat looking like a bell curve shape, um, like this, right? So we can say this is this well distributed, but I think the age column has some missing values, right? So this will also tell you the number of missing values. So you can see missing values 177. Yeah, so I actually would enjoy using Microsoft Azure than 9 because it's very detailed, but of course it has a lot of information with it. So you just need to get very familiar with it. Then this is the column on the number of siblings. Of course, the interpretation of each of these columns is available on the Cargo site where we downloaded this data from. Um, and of course, if you are working with the client's data, they would explain to you what each of these columns, what they represent, because it's very important. It's very important to understand the interpretations of the data columns so as to help your explanation of whatever machine learning process results is churned out, right? So, and then for tickets, this is also very useless for prediction. Tickets will have nothing to do with whether people survive. That's the ticket ID will have nothing to do. Then the fare. So if you look at the fare, right, you have a lot of values that are within the range of 0, right? So a lot of people on the ship paid quite a lower amount of fees. So maybe this 51, so 51 below, and you can space the bins more. So this has 10 bins. I can say, okay, give me um 20 bins so that it can spread out more. So what this bins means is that it has categorized this value. Like let's say from 0 to 50 naira, from 51 naira to 100 naira. So that's what bins mean. So categorizing the amounts that people paid, right? So if we say, okay, give me 20 category, it will spread it out more. If we say, okay, give me 50 category of 50, spread it out more. So it's, even despite spreading it out into 50 categories, we have a lot of people that paid 10 and below. So let's assume the fare is in dollars. So most of the people on the ship paid $10 and below. And you can see the spread as it cuts across. So you have someone that paid an amount so high. So this could be like an outlier, right? So you can just mouse over it and then to give you more information. So it is really very good because it helps you to quickly um, do a lot of analysis on your data and be able to see beyond what the data shows in figures. You can easily visualize your data. The visualization on Machine Learning Studio is actually very interesting. So for cabin, you have a lot of missing values. So null, you can see you have a lot of missing values. So let's look at it from up. You have 687 missing values and you have just 147 unique values. This is the first process to creating any data analytics. You need to understand your data, observe your data, look at each of the columns, check if each of them is skewed. Is anyone skewed? If any one of them is skewed, you might just want to normalize it, or if any one of them is having missing values, you might also want to um, either take out that column or replace the missing value. So you prepare or pre-process your data. So those are very important steps you must take before creating an analytics, before completing an analytics process. This is part of the creation. A lot of time is actually spent on this, especially when you are working on very large data. But this is just about 891 rows. This is very few rows of data, but of course we can still create some sense from this data. So this is our trained data, and now that we have observed the trained data, next thing is to continue our pre-processing. So okay, let's see our formatting for each of the variables and see if we need to change any of the data format. So for each of the formatting, you can see future type will tell you the formatting type of each of the variables. So for passenger ID is numeric, is fine. For survived, we want it to be categorical. We don't want it as numeric. So we are going to convert this column, right? We also want this to be categorical. P class should be categorical. Um, so we're going to convert this, right? So let's start with the data format conversion. Okay, no, this is not what I want. Okay, let's use this. So for you to create your workflow, you connect from the arrows from one node to another node. So first, to continue on the workflow, we need to convert our data set from CSV to the data set recognized in Machine Learning Studio. So that's why I need to use this. And then, all right, let's visualize. Okay, we're going to run this first before we can visualize. So to run, Okay. Okay, so I was um I was looking for the run button for the whole workflow, but for this particular one, just right click and then click on run selected. And now we can view the data set. So let's visualize and see what the data set looks like. It's still going to show as the same thing, but it's converted it now to data sets that can be used in Machine Learning Studio. Right. So, okay, so for this data set, right, you can do a general replacement of all missing values. Um, you can set missing values to a custom value option, right? But I don't want to use this because I want to treat each missing value separate. So I'm going to come to, let me just do this missing. Okay. Okay, yeah, so this is the one I want. I can specify the columns. So I can, okay, so I want to specify the column by name that has missing value and should be replaced. So let's look at our data again. This is the data. So age has missing values, right? You can see. So I want to replace age missing value with mean age, right? Um, cabin has missing values as well, right? I'm going to replace it with NA, just a value, NA. So, okay, okay, yeah, so it's populated it for us. So let's do age, right? And say okay. So for the column age, um, minimum missing value, meaning that I should replace any value that is missing. Maximum missing value, then replacement value. Want to replace it with the mean value. So you can just say replace with mean. But if you have a custom value you want to replace it with, you can just say custom substitution and then you specify. Let's say you want all the missing value to be age 50. You can do this, but I wanted to calculate the mean and then replace it with the mean. So this is going to work on just one column. But if I wanted to set missing values for everything, I can do that while importing my data set. Right. But I don't want to use this because they don't all have the same data type. So I'm going to specify my missing values um, uniquely for the column. So this for the age column. I think I want to rename this. Okay. Of course, you can view this if you want to. Just run selected, right? Then you can come and view the cleaned data. Okay, so for us to view the clean data set, just click on this rightmost column. The other one is the cleaning transformation that was done. Let's click on this and then visualize. So you can see very easy, simple drag and drop tool. So you can see it has replaced the age with mean value. This is the mean age value. So you no longer have any missing age. Age is there. But of course, you still have missing um, cabin. So we said we want to replace the missing cabin here with NA. So we're going to bring up another clean missing data, drag and drop. So I'm going to drag the cleaned data set here, right? Then come here and then specify my column. So the column, if you want to replace all columns, you can use this, but we specify, say no column. So this is like a set of rules. So rule 1, select no column. Rule 2, select column by column name. So pick a particular column. Of course, you can also pick by column indices, by column type, and maybe all features. But what we want is column name. So for this particular one, we want to replace the cabin, just cabin alone, with NA. So in this case, I'm going to use custom substitution value, right? And I'm going to use NA, like not applicable, something like that. So I can run this once I'm done. You can run each of these nodes as you are creating them. So as you are creating the workflow, you can run the nodes. So I just say run selected, Imagine if you have millions of records of rows. You can do it with this same process too. But this same thing, I can easily do it on Excel, right? But if I have very large record of rows, the performance will be very slow on Excel. And then two, the Excel has limited number of rows you can work with, but you can do that easily with Machine Learning Studio. So I can come here, right click, visualize my data. I'm going to have my data cleaned, replaced, and getting ready for analytics. Okay, so you can see all my missing cabin has been replaced with NA. I no longer have any missing values. So we are gradually getting there. Let's see if we still have any missing value. So for passenger ID, of course, we're taking it out. But the first thing is to clear out missing values. So age, missing values, none. No missing values. Then none. Right. Okay, embarked, we have two missing values. Okay. Well, for embarked, we have just two missing values. So we can replace that as well, because if you don't, your machine learning model will escape those two rows. So we need to clear out all the missing values. Drag and drop, launch selector, no columns here. Pick column by name for this particular name. Embarked. So for this one, I want to replace it with I actually want to replace it with the most popular value of, let's use a custom value. I think embarked as SC. So let's just say S. Right. So that's that. We've cleaned out all our missing values. Next thing is to um, put our convert our data sets, especially for the integer values that are categorical, into categorical values. So let's come here and convert. So we are going to use convert to indicator values. You can see it converts categorical volumes values in columns to indicator values. Let's see. So for this one, we want to change our, oh, okay, so you can see it has even identified all the categorical values. That survived P class and this and this. So we're just going to select them one by one. Okay. Then we want to replace columns. Okay, so we want to select columns in the data set that we need and exclude the ones we don't need. You can also add new columns if you are importing from another data set. I would even prefer that I do this first. So I'm going to take out this. Please, are you with me? Confirm that you're hearing me.
We are hearing you, ma'am.
Okay, great. Okay, so my cleaned data set, I'm bringing it to select columns in data set. So remember I said passenger ID will not help me in predicting anything. So I'm going to take it out. Ticket ID too, I'm going to take it out. So I come to launch column selection set. Um, so I can use take all columns, then exclude a particular column. Of course, this makes more sense. Take all the columns, then exclude the columns I don't need. Exclude passenger ID, exclude ticket. Yeah, so those are the two we want to take out. Right. Can see it's very easy to follow. So I can come to this last one and run selected. Okay, it's complaining because of this. Okay, so I may not run this last one. I can come here and say and run here. I want to see my output up to that point. Okay, now that it's done running, I'll just right click, go to my results set, visualize my data. Right, so you can see that's taking out passenger ID and then ticket ID. So this is the column that we want to use for prediction to for machine learning to learn the model. Then these are the other variables. Oh, sorry, we need to take out name as well. Name is also useless for the prediction. In fact, by looking at plot, this plot above here, you would be able to deduce easily the columns you should take out, because a column showing like this means that there's no pattern in the data, right? So all the data is the same, so this is not going to give you any information, right? But this other one will give you information, right? Even cabin too will not give us any information because most of its values are missing, even though we've replaced it with NA. So it means most of the values are NA. So I'll rather take out cabin, but for now, let's leave it there. I'm going to show us the correlation it has to the survived column we want to predict as we go on. So let's take out just name, and then once we're done, we would have finished with pre-processing our data. So where are you? Where are you? Okay, just click on this, then go to launch column selector. So okay, sorry, this is where we are. So launch column selector under select columns. So we said select all the columns but exclude column names, passenger ID, ticket ID. Now we also want to exclude is it, I think that should be cabin, right? No, sorry, let me check again. Okay, yeah, we're excluding cabin. Embarked still has some interesting information, but cabin, we're excluding cabin. So let's take out cabin. So we'll add cabin to the exclusion list. Okay, so um, with this replacement of the missing values and checking that each of our columns are normalized, then last thing we need to do to pre-process our data is to convert integer values that are categorical like to um, categorical values. So that's what it means here. Convert to um, I couldn't find categorical, but I guess this should do the work. So let's try it. So I'm saying convert these columns, survived 0 and 1, convert it to indicator column, though I wanted it as categorical. So let's run it up to here and then we view the results. So with this, we'll run a quick correlation analysis, see what the correlation to the column we want to predict is looking like, then allow the machine learning to learn the model in the data. Column with name survived is not in an allowed category. Okay. I want to see what the output of this would look like. If not, I'll take it out and we'll run the model without converting to categorical values. Okay, so let's take this out. Let me see again if I have anything convert. Okay, let's do picture selection. Okay, so this is the process of pre-processing our data. Even though I want to convert some of those columns to categorical, but I couldn't find the conversion. Let's still go on and create our machine learning model from the ready data set. So to do that, you just go to you pick the model type that you want. Okay. So remember, this is a classification type of problem because you are predicting yes or no, like 1 or 0, right? So we are going to pick from any of the classification um, buckets here. Um, so in this case, we can use a two-class decision tree. You can use any of these models actually, but let's just use a two-class um, decision tree. And the beautiful thing with this two-class decision tree is that it will also coming. Coming. Um, has something changed? Okay, so the machine learning model, right, would take in your data set and then learn the model within it. But for some reasons, I'm unable to specify the data set here. Okay, I think I'm the one who is missing something. So the model and the data set will together fit into the machine learning. Okay. Yeah. Train model. Yeah. So sorry, apologies for that. I think I was mixing it up. So for you to apply your machine learning model, right, you need the data set. You also need to specify the machine learning model type. So this is the machine learning model type we want to use for this data set. You can pick any of the machine learning model under machine learning, right? Then pick um, under initialize model. So under initialize model, you see the different classes of models for machine learning: regression, clustering, classification, anomaly detection. So if you are predicting something that has to do with values, you use regression. Clustering, if there are no labels in your data set, you use clustering. This is unsupervised. Classification and regression is supervised. I didn't go into the depth of that for this training, but um, that's just an information for you to know. Um, so for you to apply the model, you pick the model type you want. You have your prepared or preprocessed data set here. Then you pick the train model, drag and drop to. So here you supply the model, which is the untrained model, and then here you supply the data set. So this data set comes here, this model comes here, right? And then we can run the train model. But before we do that, we need to specify some values, like to train your model within the data set, which variable is the dependent, or the variable you should predict. So select a single column to show, okay, this is the one you wanted to predict. So for I want our column in this case is survived, so just pick survived. This has to be a single column because you are doing you are predicting on survived, right? So this is selected. So now I can run this model. Trained model. Okay, no, let's run selected first. If you know how to use this tool very well, is very, very good for winning competitions, also for creating machine learning projects, either for research purpose or for organizational purpose. So um, you don't have to write any code, just drag and drop, and then all of this is available for free, except when you want to deploy as a web service, you then need to buy an Azure subscription. So our model is trained. Now I can right click and view the result of my model. And then remember, I have a test data set. So I'm going to also evaluate my model on the test data set. So this is the result of my model. Um, so logistic regression uses I'm looking for confusion matrix. Okay. Okay, so let's evaluate our model. So to evaluate our trained model, we use the evaluate model value. So under this evaluate model, you are going to supply your test data set, and then your trained your scored data set. Okay, so this is our trained model. We want to evaluate. Untrained model data set. No. So this trained model, I want to get out the data set. The data set. Sorry, I need to log on again into another account and see my previous experiment. Oh, okay, yeah. So I just want to confirm something. This is another account I have, and I've created many experiments here. So, oh yes, core model. Okay, okay, okay. Let me just show us briefly what is there before I log out from it. Please confirm. Can you see my screen? Are you guys with me?
Yes, yes, ma'am.
Hello.
Yes, ma'am.
Yes, ma'am.
Yes, ma'am. Yes, yes, ma'am.
Okay, okay,
Okay,
okay.
ma'am.
So this is a workflow that I use for a different project, diabetes classification. This is the data imported. You can also write additional scripts depending on different things you want to do. I was manipulating my data sort of here. You can see the process of the workflow of pre-processing your data is basically the same. Clean the data, remove missing values, select the data set you need. You might also, in my own case, I had some skewed data sets, so I also had to normalize the data and different things like that. So this is the process of applying the model. This is the model, this is the data set. Train them, use a train model node to train the data set. So of course, it will apply this algorithm, this machine learning algorithm on this data set, and then train on the data set. So this was what I was trying to remember. So after training the data set, I need to score the model using the the the, the trained data set and the scored model. Then afterwards, I can evaluate my model. You can then also apply it on test data, on the test data set to get your results. Let me get that one out quickly. So I go back to my experiments. I'm dropping a message. Okay. So you can see that okay. Sleep. Evaluate, coming. Okay. Let me log out of this account now and go back to the previous experiment I was doing with you guys. This is it. I hope it will still allow me to be logged in. Okay, yeah. So this is where we were. So we've trained the model. The next thing we need to do is to score the model before we then evaluate. So to score the model, we click on the score model tool, right? Your train model comes here. Your data set comes here. Or I can decide to score the model on a new data set. But let's use the same data set and then let's code the model. So I don't need cross validation. I would also at some point want to evaluate my model. So to evaluate my model, I put in the scored data set. So I just right click and then we execute. Okay, so our machine learning process is complete. I'm just going to summarize again what we did in the whole process. So this is a workflow for a machine learning um, process on the data set. So we've brought in our data set. This is just a very simple data set. And of course, you can bring in many data sets as possible, and then you can use your join data and use this join data, combine data sets. Let's say I want to bring in two data sets. I can bring them in, join them together using this and bring out the results here. Um, Then we've pre-processed our data by cleaning the data, removing missing values, converting columns, and the rest of that. Then once your data set is ready, you pick the category of machine learning model that fits to the type of prediction you want to do. So if you are doing a class prediction, you pick from the classification models that I showed you here. Oops, where are you? Where are you? Where are you? Where are you? Okay, so you pick from under initialized model, you pick from classification. So if you are doing a numerical based kind of prediction, you pick from regression. If you are doing a prediction that has no class or labels, you pick from clustering or anomaly detection. So very easy, you just pick, you don't need to write any line of code. You apply your model to your cleaned data set. You score your model, then you evaluate your model. So now that we're done evaluating, we just come here, click on the evaluation results and visualize. So this is where you see the accuracy of your model, overall accuracy of your model. You also see the confusion matrix. Since this is a confusion, I mean, this is a classification type of prediction. Um, Under machine learning, you have what you call confusion matrix. You are able to see the confusion matrix with which it evaluated its accuracy. So this overall accuracy is actually based on this confusion matrix. So when it did its classification, right, 85% were predicted to be zero and they were actually zero. 14.6% were predicted to be one, but they were actually zero. So the right ones actually are the ones that were zero and are predicted to be zero, and the ones that are one and are predicted to be one. So you can see it has a high level of accuracy. Now we can apply this on a test value evaluation result. Okay, so I can decide to score this. Let me see, can it allow me say okay? Yeah, so if I'm using this for a competition purpose, like let's say I'm using this for cargo competition, machine learning competition, instead of me scoring this model on my same data set, what I'll do is I'll score it on my test data set. So remember I brought in the test value too, so I'm just going to bring it in as CSV. So I'm bringing it in as a CSV, right? But I'll then convert it to data set. Convert to data set. So this is my test data set. So I'm instead of me scoring this on this guy, I'm just going to delete this line. And then, okay, you know what? Let me bring it to this other side so it doesn't confuse you guys. Just drag and drop. That's the beauty of Azure. You actually find it very interesting by the time you use it. I remember some people in the team mentioned they're into working with data, so you can use this to create a lot of interesting insights on your data. So instead of me scoring this on my train data set, I'm scoring it on my test data set. But the issue with this is that I also need to have my data sets in this same column, is because it's going to complain. Remember, we already excluded some columns. So I also need to exclude those columns here too. If not, it will complain. So, okay, but before we do that, let's quickly visualize. Let's visualize our data set. So for the test data set, there won't be missing values. So we might not need to treat any missing values. There are no missing values, right? Okay. But what we just need to do is to remove the same columns that we removed for the train data set, so that they are same. So what I'll just do is to duplicate. I'm going to duplicate these select columns, copy, paste. So I copied and paste. So put my data set here, right? Let me run this. Okay. So I'm bringing this here. Unselected. Okay, so let's compare. We should have everything except for in 9 columns, including survived. But of course, my train data set will have 8 columns because survived will not be there. Good, 8 columns. Oh, didn't we exclude name? Oops, our prediction will be low. We need to exclude name. I need to exclude name. Name should not be there. It doesn't need name for predicting anything. Okay, so I'm going to run this again. So you just allow the process to complete. By time the process is completed, you see that all the buttons are checked. So once all the buttons are checked, you have your machine learning workflow process completed. I'm reducing this so that we can see it in one piece. I hope I haven't reduced it too much. Let me zoom out a little. Okay. So if I'm using this for a competition, right, I would use my test data set here, and then I'll score my model. Let's evaluate the model and see our results. Then I'm going to show you how to download the test submission and then you can go to your site and submit it. And this online competitions are actually available for you. You can get you can win good prizes from it. I think I know why this is complaining, but we'll come back here. Let's see our scored model. Okay, so this is our scored labels. Show is looking for okay. So the reason why it is complaining is because this column data set here has survived, right? Column. This one has 8. This one has 9. But this is just a workaround way of using the same model to predict your test. So if I'm going to use this for my test data, I'm not going to evaluate the model. I'm just going to leave it at score model, right? But if I want to evaluate the model, I have to evaluate the model on the same data set to give me my accuracy level. But I want to use it now to evaluate on a test data set. So I'm not going to use evaluate model. So like I said earlier on, if I want to use it for a competition and whatever, having run my score model is going to put in the values, the predicted values as my scored labels. So if I visualize now, I'm going to see the columns of my test data, and the last column, which is my scored label, is the new predicted values for my classes, right? So then this is the scored probabilities. I don't need this. So what I'm just going to do now is to download this data set. So come right click, go to called data set, then click save as data set. So you can give this any name. I'll call this Titanic results, Titanic competition results. So I'm saving this as a data set. Once I save it, it should reflect under my data set. You can see it's reflecting here. But you can't download it directly. You have to download it as CSV. So for you to download, just drag and drop here, then click convert to CSV, then connect it together, then run selected. Right. So I have it as CSV. I'll right click on my CSV and then click download. So once I do that, it will download it to my local system. So I'll click save as, then okay, no, this is not what I want. I think it has downloaded. Let me check my downloads. Okay, yeah, so this is it. It's downloaded. So let's look at the submission sample. Desktop. So this is the submission sample. Let's see. So this is what they want you to submit it. They want your submission to look like. Passenger survived. I is showing. Okay, so this is my submission sample. Passenger survived. Um, so I'm just going to go to my downloaded results, and then just make sure what I have there is passenger and survived. Oops. Oh, I excluded passengers. I have to put it in back. Anyways, this is what I need. This is the scored labels that I need, right? I can just copy and paste it from the test. Where is it? Okay. Copy, paste, and copy and paste your scored values from your results. Copy and paste. Right. So this is your scored value. Hmm. Me predict for the rest. Okay. There is an issue here. It didn't give me my completed prediction. Let me see. I want to check the number of rows that are here in my result set. 418 rows. Okay. Let's see what we have here as well. 418 rows. Okay. Oh, okay, okay. I think we're Yeah, 418 rows as well. Okay, so mhm. Yeah, 418 rows. Oh, okay. So okay. 418, 418. So this as well should be 418. Let me see here. For 18 rows. Okay. So my conversion should be 418 rows as well. I'm trying to pick why I'm not getting 418 rows. So this should be 418. Why is it stop at 332? View log, and view results here. Okay, anyways, because of time, so if you come to visualize here, or okay, it seems I can even download from here. I have 418 predicted rows, and I think each of them should have scored probabilities. Okay, let's yeah, each of them have scored labels. So is this scored labels result that I want to get out? Oh, okay, there are some missing values. Oh, we didn't take care of the missing values. Okay. So there are some missing values in why do I have so let's see where the missing values is coming from. Okay, there's one missing values in fair, none here, none in age. Oh, okay, yeah. So in any row you have missing values, you won't have prediction. So to take care of this, somewhere here we'll do the same pre-processing we did for the uh, train data set. We have to do the same pre-processing as well for the test data set before we can do our prediction, and then we'll have all the values. So I'm going to stop here. Um, what I was demonstrating to us is how to um, create your machine learning process for a purpose. Understand? So your machine you can have access to data to play with on many competition sites like Kaggle or Zindi competition. So on those competition sites, you can download the data, create machine learning models with your data after pre-processing it using any of these tools that I've taught you, the NIME Analytics and the Microsoft Azure platform, right? You can create that and you can submit your competition results. At least when you submit, it helps you to know if you are making meaning from your data workflow or not. You understand? So the one I just worked on now is the Titanic machine learning. Where is it? Okay. Yeah, so it's a popular introductory competition that most people use to play around with data sets. So you can also come here as well, download the data set and play around with it using Lime or using um, Microsoft Azure. Then for each of them, as you can use different models to keep improving on your scores. It's actually fun. So you can come here to play with data sets and then to see how well you understand machine learning models and machine learning process. So that's for data analytics with Microsoft Azure and Nine. I hope we have enjoyed it as well, like we
Yes,
enjoyed
my
other
yes, my yes, ma'am.
tools. Okay, so and that also brings us to the end of the training series on artificial intelligence. We have touched on different areas of artificial intelligence and other areas we have also not touched on. But these three areas, if you grab them very well and you learn and improve yourself on them, you ought to take. You have a skill that is needed everywhere and everywhere. Yeah, so, and I'm sure every one of you have need of any of these three tools. I mean, any of these three areas that we have discussed in artificial intelligence, either at your workplace or for those in school for your research or for even acquiring a new skill to be able to get into working as an AI specialist. So that's that from me. It's nice taking your class. I've enjoyed every bit. Thanks also for the encouragement from the platform. I'm happy also to have passed on to let you. Thank you all. That's all from me.
Question.
Yeah, please go on with your question.
Well done, ma.
Thank you.
Now, my question is that this machine learning is there no difference between machine learning and data analysis?
So what's your question?
My question is that as in what you taught us now
Yeah.
using the Microsoft Azure,
Mm-hmm.
it's like you are analyzing data.
Yeah.
Now, my
Okay,
question is
so
now,
what's the difference between
is there no
analyzing data and
machine learning?
oh, okay, good question. So, so analysis, data analysis is also part of the process of machine learning. But machine learning is now a step above or a step beyond to say that the machine should learn the patterns within your data and then use it to predict a new set of data. You understand? Did you get my point? So that's the difference. Or even before you before you apply a machine learning model, you also need to do some level of analysis. And those analysis are what we do in processing the data. Like we saw all the statistics of mean, median, mode, understanding if your data is skewed, normalizing the data, replacing missing values. Those are the processes of getting your data ready, and they have a lot to do with analyzing data. But most times, if you have small data, you can easily analyze it on Excel. But Excel, okay, Excel also has a new feature now that allows you to do prediction, but it doesn't allow you to use different types of models, machine learning models like you have on machine learning platforms. You understand? Excel only does like regression, simple regression model calculation for you, which is also like a form of prediction. But on other machine learning platforms where you can do machine learning process, you can apply different forms of classification, regression, decision trees, and other interesting models like that. So models basically go beyond analysis to perform predictions for you. That's the difference. I hope I answered your question.
Yes, ma'am.
Okay, good. Any other question? How many of us found this platform interesting, and how many of us will use it? I don't want everybody to stick on chatbot alone. Chatbot is the simplest of them all, but you can also, play around with this. And I remember I told you you can win money on competition sites. So get on this competition sites, play around with the data, use any of this, see dollar there. This is how some people win money online, oh, as in legal money, not fake money. But you will do a lot of work to be able to get to that point that you win money. I'm just showing you this to encourage you anyways. Are you guys with me?
Yes, ma'am.
Yes, ma'am.
Any other question or comment before we end class?
Okay. Another question. Hello.
Yes, ma'am.
Any other question?